NSCA, that was a different one. That was one we actually kind of noticed as we were already kind of doing the training study. So we had subjects that they would increase in strength, but didn't really increase in strength uniformly. We had some subjects who just it was very just steady, nice, easy increase throughout the entire training study. And then we had other subjects where it seemed like, their MVC from session to session would go up a little bit, and then all of a sudden there's one visit where it just spikes up like 30, 40% out of nowhere. And there would be others who would just seem like they would just be flat the entire time. And by the time they hit post-testing or the last visits, then it spikes up. So we were looking at those really sudden or dramatic changes in MVC strength. So we were looking at just the MVCs from pre-strength increase to post-strength increase and just seeing how those differed. Again, with that one, we didn't really see anything that statistically we could say really happened, but it does seem like that relationship for firing rates over motor unit action potential amplitude, there might be something there that's actually worth looking at. We just didn't have enough subjects to actually provide the power to actually statistically say that this is what happened. But visually, whenever we look at the graph that we ended up using for that, which was basically just a composite of every subjec's changes overlaid onto just one pre and post regression line, it does seem that the slopes post do tend to be a little bit higher. So firing rates at a given motor unit action potential amplitude are elevated a little bit. The thing that kind of muddies that a little bit, like I mentioned a little bit ago, they also did drastically increase in muscle size for the FDI, and motor unit action potential amplitudes have been shown to increase in response to hypertrophy as well. So we don't really know precisely if maybe it's a single motor unit action potential amplitude that didn't change in size that all of a sudden has the higher firing rates, or is it a motor unit that was previously smaller that started out at this higher firing rate, but then now it's larger, and so you end up looking at it as almost kind of like a shift on the graph. So it seems like that relationship is changing, really just reflects that the muscle is just bigger now. So that's something that's a little tricky, and we kind of have to figure out a more kind of clean or sophisticated way to actually kind of see if there's anything real happening there. There's a whole bunch of different, neurological mechanisms that go into producing human movement. So there's things that I'm interested in, which is neuromodulation. So that'd be represented by persistent inward currents, which are basically whenever the neuron gets depolarized, there's just the sodium and the calcium channels is persistently being open and those ions keep flowing through. So it makes it easier for a neuron to sustain firing without the brain having to provide the exact same level of stimulus as it did to initiate. So that would be something that I would be interested in looking at. That's something that at ISEC, a few of the other researchers that we talked to there and heard give their presentations were kind of hammering on. That's something we really need to look at more in this field. So that's probably where I would go.